because it's time to go back and divide those roots. So, if you can multiply them, are you allowed to divide them? Yeah, if you multiply, you should be able to divide. So, whoops, we don't want that big of bad of writing. If I said do what's square root of 21 divided by square root of 3? Yeah, just divide them. 21 divided by 3. It's square root of 7. Okay, well, that's nice if they come out that way. Or sometimes they will put a fraction inside a root. You're close. You actually can treat it like it's two separate roots if it helps you. It's the square root of 36 over the square root of 25. Do each one separately. What's the square root of 36? 6. What's the square root of 25? There you go, 6/5. No, there's not, because you did the square root. The square root of 36 is 6. Your calculator will take it to decimals. Same whole thing. Okay. So what if I give you something that's not necessarily perfect square numbers, like 20? Yeah. You can still, if you need to, think of it as two separate square roots. How do I break down square root of 20? It is indeed 4 times 5, so therefore the 4 comes out and makes a 2, and I leave 5 in. And then what's square root of 81? 9. So you can break them down top and bottom separately. That's not a major big event. Okay. Here comes the part. If I had my way, I wouldn't be teaching this to you. I personally think this is outdated, that it's not an issue anymore. I'm pretty sure you've been taught this, but here, at least in the U.S., we have not changed. Our colleges have not changed. Our textbooks have not changed. So I'm still stuck teaching with this, when I think today's technology makes this not important. But if I gave you something like 5 over the square root of 7, do you remember back from Algebra 1, is it okay to have something like that? You're not supposed to have a square root in the bottom. Okay, the reason we mathematicians made that decision back before calculators is if you were going to add this to some other fraction, you didn't want to have to do a common denominator and have a square root in your common denominator. That's just ugly and a pain. So they said, hey, let's get rid of the square roots first that are in the denominator, then it's easy to make our common denominators with our fractions. So, yeah, we have to learn how do I get rid of the square root of 7 on the bottom. Okay, you times by square root of 7 where? You actually have to do times by both. Why is that legal? Is that an okay thing? You're not breaking any rules to do that. Annie says it's like timesing by 1. She's right. Square root of 7 over square root of 7 would be like divide itself, that'd be 1. So it's like you're timesing by 1. You're not changing the value of the fraction. You're just moving the terms around. So on top we know we're just going to get 5 times the square root of 7. What's going to happen on the bottom? It's technically square root of 49, which becomes 7. And you would have 5 times the square root of 7 over 7. Okay, anybody know there's a name for this process you just did? Starts with an R. Starts with an RA. Rationalizing the denominator. If you want to get rid of the square root, you're essentially, a square root of 7 would be an irrational number. By making it become a plain fraction of 5/7, that's a rational number. So they called it rationalizing the denominator. So you're going to hear me say, when you've done some problem, don't forget to rationalize it, which means at the end you have to get rid of any square roots you have in the denominator. So if I said, what about the square root of 3 halves? Technically, that's the square root of 2 on the bottom. Times by square root of 2, which would give us what on top? Square root of 6. And the shortcut is to learn that anytime you're taking a square root times itself, the same number times itself, it's going to make a perfect square number, so yeah, it's just going to become 2. That would actually be square root of 4, but square root of 4 is 2. So if you take it a square root times itself, you just get the number that was in there. And that would be rationalized then. No yawning. And it's definitely not yawning out loud. You know, you made me have to feel tired. Alright, one more. Let me see if I can save you some time and trouble on this division thing. Some people make these kind of problems extra hard when they shouldn't. Okay, I got a square root of 11 over a square root of 12. I can't have square root of 12 in the denominator. So do I multiply by square root of 12? Square root of 12 is kind of a big number, and you have to multiply everything by 12. Bingo, yes. If you can break it down before you rationalize it, it will make your life easier. Square root of 12 would actually be 2 square 3. Okay, now, rationalize it. Now you only need to get rid of the square root of 3. You don't have to get rid of 2. 2 is just a normal number. It's the square root we don't want. So just the square root of 3. You don't need to do 2 times the square root of 3. You can do the 2 and you won't be wrong, but then you'll end up with a bigger fraction that you'll have to reduce in the end. It'll reduce back down by 2. So you might as well just only multiply by the root. You don't need the 2. In which case, this would get me square root of 33 over, okay, this would be negative 90. Okay. Square root of 3 times itself is, that's square root of 9 or 3, and 3 times 2 is 6. So it would be a 6 on the bottom. So the square root of 33 on top. 13. Alright, are you ready for the big mama? It's not that. It's going to be big horizontally. It's not going to be big vertically. Minus. Okay. Why is this one different? Yeah. I actually have a 2-term expression here. I have 5 minus 2 square root of 7. So I have part that's perfectly fine and part that has a root in it. Problem is I can't have a root in the denominator. So I need to get rid of that square root of 7 in the denominator. Okay. So what are you thinking to get rid of square root of 7? Okay. Don't write this down. If I times it by square root of 7, what would get times by square root of 7? Because, yeah, I'd like to times this by square root of 7. That would work out lovely. But wouldn't I have to just times it clear over there, too? Yeah. So, then, if I do, I'm just going to end up with 5 times the square root of 7 over here. I'm not going to get rid of the square root of 7 in the denominator. It's not going to work. So, this is a no. Don't do that. Instead, you get to learn a new term. The best way to work a problem like this is to multiply by what's called the conjugate. Ever heard of the conjugate? Yeah. You conjugate verbs and things in language classes, possibly talked about conjugates in English. Okay, let me give you an example of some conjugates here before we actually work this problem. If I give you your original function is 4 minus 3 square root of 13, its conjugate, anybody remember what its conjugate is? You're close, does not change all of them. Change one of the signs, which one? It's the one in the middle. So you would multiply by 4 plus 3 squared root of 13. You would change that middle sign, and that's the only thing. You would not change out front. Because a lot of times I get this. If people have, say, negative 7 minus 2 square root of 5, when they go to do the conjugate, they want to go, oh, well, I don't want the negative, and they'll leave it off. But in reality, that front number stays the same. It's only the sign in between the two that changes. So your conjugate would be negative 7 plus 2 squared root of 5. So if the number in front's negative, it stays negative. Now you're going, how on earth would this help me? It's just going to make me multiply tons for no reason. So, yes, when you want to get rid of the square root of 7 on the bottom and you've got two terms, you're going to always multiply by the conjugate. So you're going to have to go, okay, 5 minus 2 square root of 7, what would its conjugate be? Yes. 5 plus 2 square root of 7. But, of course, if you multiply the bottom by it, you have to multiply the top by it. So what fun mathematical operation do you get to do for both of these? It's boiling. Yes. Not completely, but the bottom does have some cool magic in it. And in fact, I want to do the bottom first so you see the cool magic. Conjugates, using a conjugate to do this, to get rid of the square root in the bottom, I'm sort of, that's one of those I'm going, who cares if there's a square root in the bottom? But the idea of a conjugate gets us out of some other mathematical issues. We even use it in trigonometry. We use conjugates working with trig functions, and it really helps. So if you're going to do the bottom, do you have to do the whole FOIL? Well, this one time, I'm going to do it all so you see the pattern, and then you can shortcut it. If you did first, what would you get? 25. Outside? Positives are 10 squared root of 7. Now, inside, you got the 5 times the negative 2 squared root of 7. Minus 10 squared root of 7. Times last. 2 squared root of 7 times 2 squared root of 7. Okay, it is going to be a negative 4. And square root of 7 times itself is 7, yes. So I would end up with, technically, I'm going to write this out again, 4 times the square root of 49, but that's really going to turn out to be 7. So if I do that, if I let that thing become 7, what's 4 times 7 then? Yep. That's maybe a 28. I got 25 up front here. I'll be able to kind of combine those in a second. What happens to the middle terms? They're gone. Kaboom, goodbye. That's the beauty of conjugates. On conjugates, you always lose the middle terms. So you actually, when you FOIL, you only ever have to do first and last when you're multiplying conjugates. The middle terms will always cancel. So that turns out pretty sweet. In the end, then, what do I have here? I got 25. The middle term's canceled. I get 28. And so, yes, I actually, out of this deal, got a negative 30. A negative 30, not 30, negative 30, sorry. Now, on top, can you cheat and just do first and last? Are they conjugates? They're totally different numbers. So, yeah, you got to do it all. So 3 times 15, or 3 times 5 would be 15. Outers, 3 times 2 squared is 7. 6 squared is 7. Insides, squared is 7. And last, 8. Yeah. And it would be plus. Technically, it's 8 times square root of 49, but that's going to be 7. And 8 times 7 is actually 56. So this part up here is really just plus 56. Okay, so now if I combine like terms, what do I have? So 56 plus 5 would be 61. 10 more would be 71. Okay, what about the inside? They did get to cancel here. Okay, it wants me to add them. So if I add them, what happens? Yeah, 6 plus 20 is 26. Yeah, so we would have a plus 26 squared is 7. Then the last thing you should ask yourself is there any chance that all of these numbers in here, all 3 places, outside the root, if I could reduce any of those? I don't think there's any common factors between 71, 26, and 3. So it sounds good. Now, the one thing they will probably make you do, some books, some mathematicians do not think it's proper to put a negative sign in a fraction. So if they don't want a negative sign in the denominator of a fraction, yeah, you need to get rid of it. Essentially what you're doing, you're moving, if you times it by -1, it's going to get rid of it here. It's going to show up here. So in reality, if you need to shift that negative sign somewhere, actually all you're going to do is just change all the signs on a period. I'm going to have -71. I'm going to have -26 squared is 7. I'll have +3. And you've got it. If it was reducible, they'd have to all be reducible by 3. And let me show you one where that might happen. Suppose I gave you 12 plus, what's a lovely number? 12 plus 15 square root of 7 all over 6. Are they all reducible by the same number? Yeah. You would do reductions. They're all reducible. You can all have 3 come out. You can take 3 out of all of them and take it down to 4 plus 5 times the square root of 7 over 2. Can I cancel 2 into 4? You can't cancel. If there's plus signs, you have to cancel into every single term. You can never do just one. If you have terms that are added and subtracted, you have to cancel into several. What you don't need. I do. For what? There's some behind the wall. You can't have it all. Some of it is going on my float. Oh, thank you, time.